this computer. Okay. So thank you everybody for being here today on our meeting of Introduction to Networks, our HBCU grant from the spring. This is our, I can't even remember what number meeting it is, but it is the 17th of May. So we're about a month, got about a month of class left for CCNA. Good question was brought up. And the question is, if you're doing the labs using not NetLabs, but you're doing the labs using Wireshark. We know there's a couple of the Wireshark labs that don't work on NetLabs right now. We're having trouble with the DHCP addresses being handed out. And I mentioned those last week. So if you'll review last week's recording, you'll see those numbers that we missed or that will not work. But the other thing is, even if you do the labs with Wireshark, and if you do some of the labs on NetLabs, the exact output is not always going to be the same of what's being mentioned inside the lab itself. Now, in the packet tracers, yes, it will be the same because that's a simulation. But in NetLabs, it's not going to be because it's real gear. So you may not get exactly what it is saying on the sheet. And that is important because when your students are working with real gear in the classroom, they're not going to see exactly what's on that sheet. And also when they get out in the real world, they're going to have to be able to interpret what they see. So that's one of the reasons why it is important that you do the labs on the real gear, because you're going to see things that are different. Now, what I want to do today is, first off, let me turn off my camera because you don't need to be looking at my side as I'm sitting here doing things. But I gave you last week the 7 holy steps of subnetting, which is a way that I have devised to do what I call classful subnetting. So when we look at a network, all right, I will say that my handwriting will be a little bit better today because I'm on a big board and I'm not on that little bitty pad. But yeah, we've got a router here. So we got a router. We got another router. We got them connected via Ethernet. And then we got 2 switches here. So there's a switch. Over here's a switch. And still my handwriting's not much better, folks, because I'm still left-handed and I'm still been hit by a truck. So I got to show y'all something. I really do want to show you something because it's I like to definitely give credit where credit is due. And this is going to be hard for you to see, but I'm going to turn it on anyway and try to show it to you as best I can. Don't you take a look at something. Really, it's a little hard to see, but you can see it there.
Yes.
That is me 5 years ago. This week.
Wow.
That is me relearning. That is me relearning how to walk 5 years ago this week. That popped up on Google, and I just, like I said, I give God all the glory because it's amazing that I can walk at all. But that's just, again, if you ever need someone.
Hey, miracle man.
Yeah, if you need spinal cord rehab, go to the Shepherd Center. But it's that I just wanted to show it to you because that actually popped up for me when I was up in Virginia Beach this week, and I was amazed. I went out for a walk, and you feel sorry for yourself because I used to go out there and run on the beach, and but after seeing that, I was like, Lord, thank you just for letting me be able to walk. So it's pretty amazing. But let's come back here a second and look at this network. We've got a network of 2 routers and 2 switches. We have. If we were given a single /24 network, so I'm going to give you this. Now I know this is typically, this would be considered a class A network, right? Because it begins with a 10. Remember our class A's are beginning with the first octet from 0 to 127.
Yes.
So class A was 0 to 127 in the first octet. 128 to 191 was a class, that's an A. This is a B, and a C was 192 to 223.
Let's see.
And then D was 224 to 239, which is multicast. So this, even though this would typically have a /8 mask, I'm giving you this subnet. So in other words, what I've done is I've already subnetted it once. I've already borrowed 16 bits to give you this subnet or this particular network. But we've got a problem here. How many host bits are on this network? With a /24 mask. Now remember, don't use the class A mask. Use the mask that I have given you.
That's 24.
Okay. So with a mask of 24, we have how many host bits? We know,
Zero. Okay.
well, we had this is our network, correct? Because it was a class A, and so the first 8 bits were network bits. We then had, since we borrowed 16 bits, these are subnet bits. Okay, so that leaves us with, since we're /24, that leaves us with 8 host bits, are all we have here. Here's our host bits. So this is still a single network of 254 hosts. Because remember that formula I gave you last week? I gave you a formula that said 2 to the h minus 2 equals the number of usable hosts. Somebody has started a loop. There you go. So if it's 2, we had 8 host bits. 2 to the 8 minus 2 equals 254 hosts. Okay. So we got a single network of 254 hosts. The problem is, looking at this diagram right here that I have, how many networks do I need? Remember we said we needed a network here.
Okay.
We need a network here. And we need a network here. So we need 3 networks. So we're going to have to subnet so that we have at least 3 networks. Now let me tell you what the curriculum is going to teach you to do. Here's what the curriculum is doing. The curriculum says, okay, we're going to use this magic number. Okay. So what they do is they take and give you this video. There's a video on the magic number. And the magic number here, I'm just going to pull this over and just kind of real quickly show you. I'm not going to.
Host.
They're basically coming in here and doing exactly what I said when we look at finding the bits turned on. So in other words, they borrow 1 bit, and you'll notice what happens is that breaks the network in half by 128. Okay. And then if you borrow another bit, you can do it, and so on and so forth. So they're showing you how to do subnetting using what's called the magic number. So if you borrow 1 bit, your magic number is 128. If you borrow 2 bits, you'll notice your magic number is 64. Okay, because it's the highest order bit turned on. And you'll notice down here, see these numbers down here, how they are breaking them down by the number of what they call the magic number. Folks, that's the variable that I have in step 6. My variable is their magic number. Okay. So you can see they just keep showing you. Okay, so if we borrow 3 bits, look what happens. 3 bits, the magic number becomes 32. 4 bits, the magic number becomes 16, then 8, then 4, and that's it. You can't go below 4. You can never borrow more than 6 bits in the 4th octet, because you've got to leave 2 host bits because of this formula right here. If you don't have at least 2 host bits, okay, 2 to the 2 equals 4, right?
Yes.
Minus 2 equals 2. So there's 2 host bits. So this, if you get down to a /30 mask, there are only 2 usable addresses. Okay. So what I want to do though is I want to take our example here that I've given you. I'm going to use, oh, it's also a neat thing about this screen is you can just, it's a Dell screen, by the way. It's a Dell monitor, but you can just touch it and erase, which is very nice. But we're going to take this network. We're going to take the 10.0.0.0/24 subnet, which I've already given you. And we're going to subnet it to match this network using the 7 holy steps. So let's go over here. Step number 1, determine the number of needed subnets. We'll go back over here. We need 1, 2, 3 subnets. So step 1, we need 3 subnets. I don't know who has the who's got the loop going on, but somebody's got someone must have the sound on twice. Step 2, is write out your host bits. So we're going to go look. We have 8 host bits here. So we're going to write out 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Step 3, using our formula, and that formula is 2 to the n equals the number of usable subnets, and n is the number of bits you borrow. This is where, if we need to, we can cheat and go over here on our sheet of paper and do this. Remember? Oops. Forget my eraser. Which is nice to be able to do that. That's a little easier than my little pad I have. 2 to the 2, 2 to the 3, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th. Okay. So 2 to the 0 equals 1, 2, 4, 8, 16. The only thing I don't like about this board is the same thing I have is I make a the sound you're hearing is me hitting the board with the pen.
Okay.
I have 12 and 10, 24.
24.
So what power do we have to raise 2 to get at least 3 subnets? The answer is going to be we're going to have to raise n will have to equal at least 2. Okay. And 2 to the second means we're going to have 4 subnets, but n right here is going to equal 2. So in step 4, using these again, turn on or set to 1 the number of bits you must borrow from step 3 and find the decimal value of the octet. So turn on 2 bits, 3, 4, 5, 6, 7, 8. Find the decimal value, which in this case is 192. Step 5, we need to find the new mask, which is used by taking the existing mask that you had before and adding your value from step 4. So it was /24. So it was 255, 255, 255. Now we add 192 to it. So 192. Step 6. Now we got to go find that magic number. Okay, I call it the variable for each octet. They call it the magic number for each octet. 6 half dozen, whichever one. You go up here and find the highest order bit turned on and the value at that bit position. So I call it a variable, which is 64. Okay. And then our last item is we're going to actually find our ranges to get our subnet ranges. We start with a major network number, 10.0.0.0 to 10.0.0.63. And then it would be .64 to 127, and then 128 to 192, and excuse me, 191, not 192. My mistake. You know, and I'll show you how I knew that immediately that I made a mistake. Here in just a second. 63, 127, 191, and then this is 192 to 255. That's a 9. Okay. You'll notice everything on the left-hand side is even, everything on the right-hand side is odd. You also know that because of our formula, and again, going back to our formula, 2 to the h minus 2, which gives us a number of hosts for each one. Remember, this first address is the subnet ID. The last address is the subnet broadcast ID. So here on this first one, all of the host bits are right here. All the host bits are zeros. Over here, all the host bits are 1s. But now we could come over here and actually start assigning IP addresses. So we could go to this router right here, and on that gigabit interface, so on G000 or 001, either one, you could put, actually I'm going to use 001 because I like using, when I'm doing networks like this, I like to use G001 as my inside because 1 looks like an I for inside. I use G000 from outside because 0 looks like an outside. But we could put the IP address here of 10.0.0.1 / what would be my / notation now for this new mask after we've subnetted?
24.
Say what?
You said 24.
No, it's not 24. It was 24 to begin.
But you have one there host now.
But we borrowed 2 bits.
Okay. That's
So
16.
the new mask is
18.
26, because we borrowed 2 bits. Now, everything down here could be up to the last usable address. If we put that on the host, it would be 10.0.0.62/26. Okay. And then we could go right here. This could be 10.0.0.65/26. This could be .66/26. Okay, and then all the way over here, we'll go to 10.0.0.129/26. And then the last usable address that we could use would be 10.0.0.254/26. You'll notice we've used the .0 subnet here. So this is the 10.0.0.0/26 subnet. This is the 10.0.0. Let me get that, fix that. Sorry. This is the 10.0.0.64 subnet/26. And then over here, I used actually that would not work. Y'all should have stopped me. I was on a different subnet. What's the last usable address in this subnet, in the 128 subnet? It's this subnet right here. What's the last usable address in this one? It would be 190, correct?
Yes.
It's 190. That's our last usable. Okay. So this is the 10.0.0.128/26 subnet. So I've got 4 subnets when I borrowed 2 bits, and I've used 3 of those subnets on my network. This is no different, folks, than what they've done right here. They just went in here and did this. Okay. They used their magic number method right here.
I now have /20.
See what they've done? So they just took the same thing. It was a /24, and they did start with a class C, but it doesn't matter. As long as it's a /24 and you're borrowing bits from it, this will work just like this. All right. Questions about subnetting in especially anything past /24? Here's where things get a little weird. This is where people have a lot of trouble using the method that is being used called that is called the magic number. This is where I think for classful subnetting, my method works even better. Okay, so let's go back over here for a second and let's create a new page here. And let's say that I'm giving you the network 10.0.0.0/8. And I want you, okay, step number 1 is determine the number of subnets you need. And I say, I want you to have 1,000 subnets. All right. Let's go over here. Let's do our little cheat sheet. Let's not confuse ourselves. Let's go ahead and cheat. By the way, again, I would do this every time I take a certification exam, a Cisco certification exam. Before I ever click start, I write this on that little grease board they give me, because that way I won't make a dumb mistake.
64.
That's 2 to the 10. It's 1024. Okay. So step number 2 is write out your host bits. Now, folks, this takes a long time with a class A like this, but I still like to do it until students get accustomed to doing it. 2, 3, 4, 5, 6, 7, 8. Because what is the definition of subnetting? What did I tell you last week it was? The book definition of subnetting.
Subnetting a network.
Subnetting a network. I also said that subnetting by default. I don't know why you've got that the feedback today. Maybe something the way I've got it set up in here. I don't know, but subnetting is the process of borrowing host bits to increase the number of network bits. Number of network bits. So that is the book definition of subnetting. So every time you subnet, you get more networks, but each one of those networks has fewer hosts on it. So we'll go back over here. We've got, in this case, we started with one network. Okay. We started with one network, 10.0.0.0/8. How many hosts are there on each one of those on that network right there, class? What's the formula? Anybody? If you can put it in chat or you want to try to put mention it, just let me know. I am recording. Thank goodness. I'm scared to death. I forgot to record. What is the formula I gave you to determine the number of hosts on a subnet or on a network?
That's going to be the formula.
2 to the h minus 2. There it is, right there. Thank you.
Okay.
2 to the h minus 2 equals the number of hosts. Yep. And h equals the number of host bits. So in this particular network right now, I have 2 to the 24th minus 2, which I believe if I do the math, it's 16 million and change. Somebody do that for me. It's 16 million hosts. I believe that's correct. 16,688,000 something in that neighborhood, but a bunch. Okay. Not very useful for most networks. So we need 1,000 subnets. We're going to do step 2, write out our 24 host bits. Step 3, we're going to use our formula, 2 to the n equals, and we need it to equal 1,000. At least 1,000. So what does n need to equal for us to get at least 1,000 subnets? All you got to do is go over here. 2 to the 10th power, okay, is 1024. So if n equals 10, then 2 to the 10th power equals 1024. So 1,024 subnets. Step 4. Now this is where it gets a little bit weird. You must turn on or set to 1 the number of bits you must borrow from step 3 and find the decimal value of that octet. Well, and this is the first case where we have crossed what is called a bit boundary, or in other words, we've crossed an octet. So we're going to turn on 10 different positions. So we look at our host bits up here in step 2. We turn on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4, 5, 6, 7, 8. And then convert that to decimal, and you'll get 255.192. All right. Step 5, find our new mask. All we do is add the value we had from the beginning. We used to have 255.0.0.0 because it was a /8 up here. Now it's becoming a /18. Okay. So it's 255.192.0. That's our new mask. Step 6. Now here's where things change slightly in my formula. The 7 holy steps of subnetting. The base 7 holy steps of subnetting are made just for anything that's more than /24. If it's less than that and you're subnetting, then what you have to do is you have to find the variable in each octet. So we're going to go up here and we're going to find the highest order bit turned on. So we're going to see that the variable in the second octet equals 1. The variable in the third octet equals 64. All right. And then last but not least, we got to find our ranges. Now, this is where people get the most confused, but it's really extremely easy. So what we're going to do is I'm going to give us some room here. So we got a little bit of room. I am going to get rid of that just so we got some room here to make to do it. All right. So we start with our major network number. So this is step 6. So 10.0.0.0. All right. We then need to roll the third octet by all possible combinations, okay, of the variable here. So in the third octet, our variable is 64. So we go 10.0.63.255. You'll notice we don't do anything to the fourth octet. We use its entire value of 0 to 255. We also make no change in the second octet yet because we've got to roll the third octet by all its possible permutations. So our next subnet will be 10.0.64.0 to 10.0.127.255. And then it would be 10.0.128.0 to 10.0.191.255. Then 10.0.192.0 to 10.0.255.255. Now, what do you think the next subnet would be? What's the next range? Anybody? You can put it in chat. You can put it here. I want you to notice we rolled the third octet by all possible permutations using our variable. Okay. So now we should move over and roll the second octet by the variable. So now it's going to be 10.1.0.0 to 10.1.63.255. And it will be 10.1.64.0 to 10.127.255. I'm going to skip down below here and do the next one. 10.1.128.0 to 10.191.255. 10.1.192.0 to 10.1.255.255. And my next subnet would be 10.2.0.0 and all the way down until I had 1,024 subnets. So we took a /8 network. We borrowed 10 bits from it and we made 1,024 subnets. And each one of those subnets will have 8, 9, 10, 11, 12, 13, 14 hosts on it, or 2 to the 14th host on it. Does this make sense? Okay. Let me ask you a crazy question. Now, you know this is now /8, 16, 17, 18, so it's 8/18. All these are /18s now. Using the /18 notation. Okay, so in this first subnet here, I'm going to erase below this. So I'm going to give us some room here so we can just look at something. Inside this subnet, tell me, is this, well, okay, erase, get rid of that. There. Is this a usable IP address? Can that IP address right there be given to a host? Anybody in class that wants to respond, you're welcome to respond. And then, but I want you to tell me why why it is or it isn't a usable IP address. Anybody? I don't have to call on somebody.
Let me ask you a question.
Okay.
When you're on the right side, because I'm looking at what you have there, which is like, they call it subnetting the table, which is start from 1, 2, 4, 8, 16, 32, 64, 128, 256, 512 to 1220. And if we are giving the number of hosts to designed, I was looking at the book, and then they start to be increasing it by 4 from the 00 towards the end of the 4th octet. Anyway, I get the, I'm trying to match the method that you are using to the one that they have in the book, and then so
be aware. So one of the things they're doing in the book, especially as we move forward to BLSM, is they're going to look at it a little differently. They're not going to look at the number of subnets. They're going to look at the number of hosts left on each subnet.
Yes, they look at it in that way.
Right. We're going to get there. We're not there yet. Okay.
Oh, okay.
I want you to learn, I want you to understand what I call classful subnetting first. This is a method where we subnet so that everything is the exact same size. All the subnets have the same number of hosts on them. Once you understand this, then it's much easier for me to teach you what they're trying to teach you. Okay, so we're going to get there. Just hold on just a minute. Okay. But is this a usable IP address? Can it be assigned to a host?
I'm gonna say yes.
Yes, the answer is yes. Why? Well, first off, let's look. The first usable address in this subnet would be .1, correct?
Yes.
The last usable address would be 63.254. So this number sits in this range. Okay, so it's a usable address. The other thing we're going to realize, if we convert this to binary, so let's convert it to binary. Let me make us some space here. Here's how you, if you ever are asked on any exam or you're asked anywhere, is an IP address valid to be placed on a host? All you have to do is this. You convert it to binary. So 10 is 128.64.32.16.8.4.2.1. 0 is easy because it's all zeros. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 8. And then 255 is 1, 2, 3, 4, 5, 6, 7, 8. Okay. We know the first 18 bits are network bits. So we'll go, here's 8, 16, 17, 18. Okay, so those are network bits. Now, I know that this part is actually network and this is subnet, but still, that's our subnet ID. But now take a look at all of our host bits. Okay, so all of these are host bits. Are they all ones?
No.
And no, not all of them are ones. Now, 1 octet full is ones. Okay. But are all of these ones? No. Are all of these zeros? The answer is no. So an IP address, when you compare it to its subnet mask, as long as in the host portion, it is neither all ones or all zeros, it is a valid IP address that can be assigned to a host. So if you ever get a test question and it says, and it can be something as simple as this. It can actually be, I'm going to give you the address 192.168.12.35/24, or excuse me, /27. is that a valid IP address to put on a host? And what you would have to do is convert it to binary, check the host bits, make sure all the host bits are neither ones or zeros. Okay, which I can do this easily because I know these, that was supposed to be a 12 there. I know that with this particular network, these are all network bits. And then so I convert 35 to binary. So 128, 64, 32, 16, 8, 4, 2, 1. All right. And so /27. So the first 3 bits are subnet bits. And so now I'm looking at my host bits here. All the host bits are not ones. All the host bits are not zeros. So I know that that could be an IP address that could be assigned to a host. And what about this one though? Which is, oops, golly, wrong thing. Okay, let's make this 32. Now look what happens. Now, all the host bits are zeros. Okay, so I know this is a subnet ID. That 32 is a subnet if you're using /27. If it was .63 /27, I would have all ones here. That's 63 in binary. So now you'll see in the host portion, I have all ones. So that's the broadcast of the .32 subnet. So if you ever need to know whether or not an IP address is valid to be placed on a host, this is exactly how you do it. You just look at it and compare it to its subnet mask, find the host bits, make sure they're not all ones or all zeros. If they're not, it's a valid IP address, even if it looks weird. Okay. Questions? They're showing you the exact same thing here. They just did the magic number version. So they say, okay, if we borrow 10 bits, we get /18 network, and we're going to have 2 different magic numbers. We're going to have one in the 3rd octet, and we're going to have one in the 2nd octet when we get through it. So you see, they're doing exactly what I did. You can also do it in binary if you wanted to do it. You can actually write it out in binary and do it. So if you're a mathematician and that's your thing, you can show this purely in binary. I've found my students do not understand it in binary and cannot comprehend it fully in binary. So I have to kind of give them a little bit of a cheat sheet to make it work. Okay. Questions about this? Okay, let's back up just a second, because one of the things that we should have noticed at this point, we should have noticed how inefficient this is. Okay, I mean majorly inefficient. Let's take a peek at this network right here. I subnetted this, okay, and so I broke it into 4 subnets, but I still ended up to where on this link right here, okay, which is a point-to-point link, I used an entire subnet of 2 to the 6 hosts, so 62 hosts. I used a subnet of 6. Wow, sorry, y'all. I used a subnet of 62 hosts right here for a link that has at most 2 hosts. So what if we could subnet a different way? What if instead of having to use the exact same mask on every single one of our networks? Okay, so in other words, all of these are /26s. What if we could vary that mask to meet the requirements of the number of hosts that are on a particular network? So that, ladies and gentlemen, is called variable length subnet masking. So VLSM. It is also sometimes called classless subnetting, but this is variable length subnet masking. And this is, I think it was Jacob was making, or Francisco was making a question about, they want you to look at the number of hosts per network instead of the number of subnets that you're going to need. But let's look at this. So let's imagine we've got a network where we've got one router here, another router there. Down here, we've got a switch. And we're going to have 60 hosts here. And then over here, we're going to have 10 hosts. How many hosts do we have right here?
My total is 670.
It's 2. There are 2 hosts here because that's a point-to-point link, right?
Okay. Yeah.
So point-to-point link. Now, any of you, if you're actually working out in the real world networking, there used to be a thing we could do called IP unnumbered, where we could actually borrow these internal addresses and use them across a point-to-point link. You may read about that. You may see that in a book. We don't do that as much anymore because we just go ahead and use a /30. But be aware, if you ever read about IP unnumbered, that is an older technique that we could actually borrow the inside IP addresses here on these outside interfaces. We don't do that much anymore just because of the confusion it causes. But let's imagine, I'm going to give you the same network, 192.168. 12.0 that we've been playing with /24. Okay. But now we need to, instead of trying to determine the number of subnets, we need to play with the host bits to leave X number of host bits. So what we need to do is we need to put our handy dandy chart back on the board, because without this, we make dumb mistakes. And eventually you will not need this, but again, until we're very, very comfortable with it, we'll continue to place it on the board just for simplicity's sake.
16, 32, 64, 128.
I could really have stopped up at 64 with this, but now, first off, how many host bits do I have in this network to play with?
8.
8. So let's go ahead and write out our 8 bits, because again, I want you to realize subnetting, 1, 2, 3, 4, 5, 6, 7, 8. Subnetting is the process of borrowing network host bits to increase the number of network bits. We need a network of at least 60 hosts. So to find out how many host bits I must leave, I would use my formula 2 to the h minus 2 equals the number of usable hosts. Okay. So what does h have to be in order for me to have at least 60 hosts available?
6.
That's 5.
6. It had to be 6, because if it was 5, it would be 30. So 2 to the 6th minus 2 equals 62 hosts. So in other words, it's saying I've got to leave 6 host bits. So what we do then is we come over here and we say, okay, I've got to leave 6. So that means let's turn on the first 2. All right, you with me so far?
Yes.
Now, guess what? We could use our 7 holy steps from here. We're already at step 4, right? We know we've got to convert this to our new mask. So this is going to be 192. So, and this is basically step 4. Step 5, our new mask is 255, 255, 255.192. All right. With step 6, we need to find our variable. Well, our magic number or variable is 64. And in step 7, we find our ranges. So 192.168.12.0 to 63, 64, 127, 128 to 191, 192. 255. Now, here's where I diverge from the curriculum, and this is where I totally disagree with what the curriculum teaches you to do. The curriculum teaches you to take, since this is now /26, right? The curriculum would say, take this block right here and use it for your 60 hosts. Okay, so I'm going to do it the way the curriculum teaches. So 192.168.12.0 /26. So this network right here, we could put .1/26 here, and we could use up to .62. The curriculum would then say, okay, at this point, what we could do, if we're going to use BLSM, is we need, or we should have, okay, this is still too big, right? This is still, we don't need 62 hosts. We need to take these and break it down to where we have fewer hosts on each subnet. So let's just take this second subnet and subnet it again. So we're at /26 right here. Let's do /27. What would the magic number be if it was /27? It would be 32, correct?
Yes.
So we'll go 64 to 95 and 96 to 127. I think that's right. I did my math right. Yep. Okay. How many hosts are there on this on each one of these subnets? If I borrowed one more bit, it'd be 2 to the 5th. So these subnets each have 30 usable hosts on it. Still more than what I need right here for the 10 hosts. So we could just say, all right, well, I'm just going to take this subnet and subnet it again to /28. It goes here. My variable now is 16. So 64 to 79, 80 to 95, and that's where the numbers really start looking weird. And at this point, that is a network of up to 14 hosts, and that's as small as I can get it and still support 10 hosts. So I could come over here and say 192. I could do 192.168.12.64/28 would be the network I put right there. So this one's been used. Okay, so that one's used. And then we could keep subnetting on out. Okay, so we take this 80 to 95 because we need one more network of 2 hosts. We're going to subnet it again, which would be /29. And that's going to be a value of right here, 1248. So it would be dot 80, 87, 88 to 95. I believe that's correct. That's my math wrong again. Nope. 90. Nope, that's correct. And then you go all the way down to /30, which would actually be 80, 83, 84, 87. Okay, and that would become the network for these 2 hosts. And this is why I think the method in the curriculum is terrible. Nobody puts these numbers on their serial links. That's the dumbest thing ever. Okay. Real world, this is what we would do. Real world, let me show you exactly what we're going to do. We're going to do this. We're going to get rid of all this. We would not have put this /0 right there. We would not have put this here. What we would have done is we would have broke this .64 out and we would have put it right here. So we'd have done 192.168.12.64/26, and we would have put it right here. That would have been the network for this particular setup. Okay, so there. We would have then taken this, the .0, would have borrowed another /27 now. So we made this 0 to 31, 32 to 63. Still too big because it's got 5 on it, so it's still still 30. Then we would have done a /28, and this would have become 0 to 15 and 16 to 31. We would have pulled this out, so it'd been 192.168.12.16/28. And then we know at /30, we can use .0 to 3, .4 to .7, .8 to 11, and .12 to 15. Okay, and we would have pulled this for right here. 192.168.12.16 168.12.0/30. I'm going to use .1 here and .2 here. That's what we do in the real world. Okay. The curriculum is going to teach you subnet it for the biggest piece, the most number of hosts you need, which in this case was right here, we needed 60 hosts. Okay. It's going to say, pull that very first piece out and use it. Real world, no. Real world, we're going to leave that first piece so we can use the numbers that we're easily able to find for our /30s. Any of you that are in this class that work on your network group, is that not what you kind of do on your networks? It makes life so much easier because you know what your /30s should be. 0, 4, 8, 12, 16, 20, 24, 28, so on and so forth. Okay. Questions about that? What we're doing, by the way, folks, let me show you something. All we're doing when we're doing VLSM is we are subnetting a subnet. So this is a /24, right? So we borrow 1 bit, and remember our magic number or our variable at this point is 128. So we got 0 to 127, 128 to 255. And notice I'm not pulling numbers out of a hat. I'm simply breaking this down into 2 pieces based upon the variable at that particular slash. Next, I do /26. My variable is 63, 0 to 63, 64 to 127. Now the beauty is, if I needed a big piece, if I needed a piece that had 126 different hosts on it, I could pull that piece out and use it, or I could just leave it there if I didn't need it. And I can just keep going. And you'll notice what ends up happening is we can have different subnet masks for different links so that we more efficiently use the IP addresses that are assigned to a link. Word of warning. Let me give you a real quick word of warning about networks. Okay. One thing they're going to teach you here with VLSM is they teach you about conserving, about VLSM. They talk about how you can subnet a subnet. But the one thing they don't teach you about is what I call the rabbit theory of networking. Okay. If this particular building A has 25 hosts in it today, when you're subnetting for that building, plan on between 50 and 80% growth in the next 3 years. Because hosts are like rabbits. If you got 25 of them today, you'll have 50 of them tomorrow. All right. So be aware, just because it says that. Now, that's where we've got to talk just a little bit about what I call and what I teach my students. There are 3 worlds out there. Okay. There is what is known as our book world. Okay. In the book world, we may do it exactly, the way the book says. So in other words, if I look at this and I'm asked, okay, book world, it says it needs 25 hosts. I'm probably going to subnet it to have 25 hosts. All right, there's the book world. We have the exam world. Okay, so I'm going to take my CCNA. I'm going to take my CCNA, folks, and the question says, subnet it for 25 hosts or get as close to 25 hosts as you can. And it says nothing about planning for growth. You're going to subnet it to get it as close to those 25 hosts as you can. Because in the exam world, you've got to do exactly what they ask you to do. And then there's this place that we really live, and it's called the real world. In this world, I teach my students this. If I had this design right here today and was handed this as a network engineer, I would actually plan for at least 75 hosts in building A. And in fact, I would probably plan for no less than 100 to 200 hosts in each building today when I was doing my subnetting. And in fact, I would probably cheat. Let's see if I got a snipping tool here. Because what I would do, if this was a real world. Oops. If I was building this real world, okay, and this was what I was given. So that's my network. That's what I'm being asked to build today. What I would do, quite honestly, is I would say, all right, well, I know what's going on, what's going to happen. So more than likely, I would make this a 10.0.0, actually 10.0.1. 1.0/24 for this building, 10.0.2.0/24 for this building, 10.0.3.0/24 for that building, 10.0.4.0/24 that building. That gives me 254 possible hosts in each one of those. And then right here, I'll do 10.0.0.0/30. And then this one will be .4/30. This will be .8/30 for my serial links. So this, folks, is that real world.
I have a quick question.
Shoot.
All right. So when I teach my students about subnetting, we cover an aspect in doing this called anding. Where do they cover that in this?
It is covered. Let's see, where did we get that at? It was way up here in, let's see, where did we get that? Was it here? Oh, nope, there. It was right. I know we covered it. It was, I think it was right here. Yeah, right here. So right there, 11.1.4. So it's in this same section. So it is covered. Yeah, we went over it last week, talking about Andy.
Yeah, because that's how I teach them to do subnets for when they have basically what you just did.
Right.
With having the 10.1, each of them has a different a different octet, but using anding, and then they have, this is so that they don't end up crossing.
Yep. Because what you can do with anding is if you take any address and and it to its mask, the actual network address falls through. So and I'll be quite upfront with everyone. Hey, I'll be completely honest with you. There are multiple ways of teaching this. I've already taught you the 7 holy steps to do classical. We talked about the magic number. We've talked about using VLSM. There's also multiple other methods to teach your students. And one of the things I have to do many times if I'm teaching a student class is I will teach them a method, and then I have to ask another professor to come in and do a lecture on subnetting, because I can tell them till I'm blue in the face. And for some reason, they just won't understand it when I'm talking about it. But as soon as another professor comes in, they will understand it. But this is the most important thing we cover, period, in CCNA 1 by far. If a student leaves our programs and doesn't understand IP addressing and doesn't understand subnetting and VLSM, we have failed them miserably. Now, they don't have to be an expert mathematician, but they need to understand it and hopefully be able to at least look at it and figure out what subnet a particular IP address is on, and what is meant by certain slash notations. But yeah, anding works great, and it is covered here in the curriculum. There's even an activity which is really kind of cool, which has them put in the, it's like a flash. No, it's not flash anymore. I guess it's just HTML5. But it allows you to put in here, and they can put in particular values.
Which of the two do you think is a better method to do, doing the anding method or the method that we were just going over?
I've done this a long time, and you have to understand, even though I had 3 years of biochemistry, both my degrees are in English. Okay. So take that with a grain of salt. So that's why this, for me, as an English major, helped me to really understand what was going on. Now,
Okay.
for your mathematically inclined students, I think the ANDing method will work very well, or the magic number method. They work well too. But I think if we show them all these methods, you're going to get all your students. You're going to get them. The math students can go, oh yeah, I understand this ANDing. But your students who are not quite as math inclined will be able to go, well, I can do it this way. I can use the magic number, or I can, 7 holy steps, again, only works if you're doing classical subnetting. So be aware of that. It's not really designed for classless or VLSM, but it's still the basis for VLSM. And that's why I worry about this curriculum a little bit in this area. They don't teach classical subnetting. And I think you need to know that before you go into VLSM.
Okay.
It also helps you to be able to say, hey, you know what? The reason we got to have VLSM, because look, we're wasting all these addresses if we don't.
Exactly.
Yeah.
You only want to use.
Go ahead.
You only want to use enough and have enough for growth.
Right.
So that you don't need a full class C and you only have two hosts on the network.
Yeah, it's just a massive waste of space. Now, again, I still make sure we always tell them this, because it goes back to, again, on the exam world. Oops, excuse me. Oops. Do away with both those. In this world here, when if the exam world is there and it says 10 subnets, you get as close to 10 subnets as you can. All right.
Okay.
Book world, and so in other words, like if you're taking a quiz inside of the curriculum, unless it tells you specifically, you get as close as you can. If it says 10 subnets, unless it says allow for growth, you get as close to 10 subnets. Real world, I'm saying 50% growth at least.
Okay.
Except on your point-to-point links, because typically point-to-points between buildings and things like that, you're not going to have a lot of growth there. Plus, if you needed to, you can do what's called a sub-interface, or you can do other little tricks between different buildings. But that real world is you'd be amazed. Students get out in the real world and they paint themselves into a hole with a subnetting scheme, and then you have to renumber your entire network, and nobody.
Which is a pain in the what's it.
Oh, it's horrible. Yeah, that's a bad day when you suddenly realize, oh man. I'll give you a great example of a real world here. And this is something that probably a lot of people do. Show my video just a second. But so we've got our building here. So this is, well, I get the right thing. So here's our building. This is the Whitley building. Here's another building on campus, and there's several other buildings on campus. But for our buildings, this may be 10.200.0.0/16. Every network in this building is in that 10.200. This building may be 10.300, can't be 300. 10.201, 10.201.0.0/16. So in other words, inside of our buildings, we may have a classroom that is 10.200.1.0/24. We may have another classroom that's 10.200.2.0/24. Okay. But the beauty of this, if you design your network this way, when you run your connection back to your core, you can summarize so that your core only needs to keep one route to that network to cover every single network that's in the building. So, and that's kind of advanced subnetting, advanced network design that's not really in CCNA, this portion. We do talk about it as we move forward. But if you can design your network this way, then you can do summary routes so that instead of having to have, if there's 25 networks in this building, instead of having to have 25 different routes, as long as I make sure they're all under this /16, then I can just have a single route or a couple routes. Usually it's not just a single route. You normally have a route for our wireless APs. We have a route for maybe security cameras, route for other things, because some of those things travel across tunnels or VPN tunnels or network tunnels, IPsec tunnels, back to a controller. But still, if we can go from having to do 25 routes out to a building to doing 2 or 3 routes to a building, it makes it much simpler for our core networking devices to be able to handle that. Okay. Any questions? Any other questions? I'm going to stop. That's pretty much what I had for today, folks. Any questions on what we've been going over, or any questions? I would love if anyone wanted to show their method of subnetting next week, we could do that as part of class 2. So if you wanted to show how you do it, I'm more than happy to let you show other folks. If you work together and all of you are at a school together, like many of you are at Hampton together, I strongly suggest that you work together to help teach these concepts for one another. Your students, a lot of times, especially our students that get out in the real world, they start using subnet calculators, but they don't understand where the numbers are coming from. So that's a problem for them. Okay, I'm gonna stop my share. Are there any questions about what we've gone over? No questions at all? I'm gonna stop the recording.